So today we're going to start our polynomial unit, and a polynomial is something that looks like this. So we're going to talk about how to add them, how to subtract them, how to put them in order, and then how to determine what degree the polynomial is to. For our first example, they gave us two polynomials, polynomial 1, polynomial 2. First, we're going to add the polynomials together, and then we're going to talk about how to subtract polynomials. So I'm adding my two polynomials. I have w cubed minus w squared plus w minus 1, and then I'm adding this whole polynomial to it. So 1 minus w squared minus w cubed. I can only combine my like terms. So I'm looking at this and I have w cubed. I can only combine it with another w cubed, and I see that's there. W cubed minus w cubed gives me nothing. Those cancel each other out. So then I'm looking at the next piece, which is negative w squared. I can only combine it with another w squared. I see I have one right there. Negative 1 minus 1 gives me negative 2w squared. I'm now looking, and I see I have this w. I can only combine it with another w. I see one here. W minus w. Oh, that gives me nothing. And then I have negative 1 plus 1, which again gives me nothing. So when I added these two polynomials together, I ended up with negative 2w squared. So let's see what happens when I subtract them. When I subtract two polynomials, I'm going to write it like this. My first polynomial, w cubed minus w squared plus w minus 1. And I'm subtracting this whole thing. I'm subtracting every single piece. So when I subtract, I personally like to distribute this subtraction sign to all of my pieces first, so you can see what subtracting a negative really is going to mean. So I'm going to rewrite this with the negative distributed. So I have w cubed minus w squared plus w minus 1. This turns into a negative 1. This guy's going to turn into a positive w, because negative times a negative is a positive. This one's a positive w squared, because negative times a negative is a positive. And this one's going to be positive w cubed, because again, negative, negative, positive. Now I can combine my like terms. I start with the first, w cubed, looking for another cubed. There she is right there. I'm adding two of them together, so I end up with 2w cubed. Now I'm looking at my w squareds. This one's negative, that one's positive. They cancel each other out. There's not a whole lot to do with that one. With the next one, I have a w plus a w, which means I have two w's now. And then the last one, negative 1 minus 1, which means I have a negative 2. So when I subtracted my polynomials, I ended up with the big polynomial of 2w cubed plus 2w minus 2. Taking what we know about adding and subtracting, we're going to move to a different kind of problem. With this problem, we need to do three things. The first thing we're going to do is combine like terms. Then we're going to take that answer and make sure it's in order. So I'm going to talk about what that order looks like. And then once it's in order, we're going to decide what the degree is. So first and foremost, I want to combine my like terms. Like terms are all determined by the variable. And so this has an x squared, this first term has x squared and y cubed. So I'm looking for any other term that has x squared and y cubed. That doesn't, that doesn't, that doesn't. So I can't combine him with anything, so he's just going to stay the same and be on his own. Now I'm looking at this term right here. I want to see, does anything have one x and two y's in it? This one doesn't, but this one does. I can combine those together. So negative 1 plus 2 gives me just 1xy squared. And then this guy is x cubed, and so I can't combine him with anything. So he looks like that. Once we have combined our like terms, we got to make sure it's in order. And how you make sure it's in order is first, the variables are always going to be arranged alphabetically. So that's why they have x, then y, x, then y, x, then y. So I want to look at the exponent that goes with my x. Whichever has the biggest exponent needs to be written first. This one's got a 2, he's got a secret 1, he's got a 3. The one with the biggest exponent needs to be written first. So in order, this polynomial would look like this. He would come first because 3 is biggest. Then the 2 would come next, so it's 4x squared y to the third. And then last but not least is the x that has the power of 1. And so this is that polynomial in order. Now I have to decide what is the degree of the polynomial. I determine the degree by taking all these monomials and adding their exponents together. Whichever one's the biggest is the degree of the polynomial. So this guy has an exponent of 3. He's got a secret exponent of 1. So this monomial has a degree of 4. This guy's 2. This guy's 3. 2 plus 3 is 5. That monomial has a degree of 5. This guy's 1, 2. Add them together, I get 3. Which one's the biggest? Well, 5's the biggest. So this whole polynomial is a 5th degree polynomial because the biggest monomial has a degree of 5 because I added the exponents and got 5. So it's a 5th degree monomial. So now I want you to come see me, and I'm going to have you do those try it on your own problems. We'll go over them, and then I'll let you know what your assignment is.